We are completing a dosing problem. In this case, the physician has ordered 0.15 grams of the medication every 6 hours, and we're asked how much medication should you prepare per dose. So when we look at the label, we see that this medication comes in milliliters, so we want our answer to be in milliliters because that's how we would prepare the medication. The first approach that we'll use is the dimensional analysis approach. So we take what is ordered, the 0.15 grams, and we place that over a placeholder 1. We're going to multiply, and when we multiply, we want to cancel grams. When I look at the strength of the med, it's in milligrams, so I'm not quite ready to use the strength of the med. So I'll use a metric conversion. I know that 1 gram is equivalent to 1,000 milligrams. And this allows me to cancel the label of grams. Now I'm ready to cancel the label of milligrams, and I can do this using what is on the label. You'll notice that the strength of the med is listed twice, 500 milligrams per 20 milliliters, or in reduced form, 25 milligrams per milliliter. Using either strength will give you the exact same answer. So I'm going to use the one that's big and bold here and easy to see. So I'll have 500 milligrams, which is equivalent to 20 milliliters. And that allows me to cancel the label of milligrams. So when I look at my math, my labels have canceled to give me milliliters, which is what I want. And so I do the math on my calculator, 0.15 times 1,000 times 20 divided by 500. And I come up with an answer of 6 milliliters. Our second approach is to use the nursing formula. This starts with the desired amount or doctor's order, which is given in the prompt of the problem, so 0.15 grams. We place that over what we have on hand, and again I'm going to use the one that's in bold as the strength, but either one would work. So I have on hand 500 milligrams in a quantity of 20 milliliters. Now I'm not ready to do the math because my labels don't cancel. So I have to use my metric line. I remember the mnemonic device, King Henry died by drinking chocolate milk full of microorganisms. The G is a base unit, and so I need to move my decimal 3 places to get to the M for milligrams, and that would give me 150 milligrams. Now my labels match, so they cancel, and that means I'm ready to do the math. So 150 divided by 500 times 20, and that gives me an answer of 6 milliliters. My final approach to this type of problem would be to use a proportion. A proportion is made of 2 equal fractions. Like the other approaches, I always start with what's ordered, 0.15 grams. In this approach, I place it over X milliliters. That's what I want to convert it into. Put an equal sign because I am making equal fractions. And I put the strength of my med, so 500, which is milligrams, over 20 milliliters. Just like the other approaches, I could use either strength of the med, the one that's in bold or the reduced form below. This proportion is not a true proportion. It was a good attempt, but in proportions, the labels must be equal, and they are not. So again, I need to use the King Henry mnemonic device. King Henry died by drinking chocolate milk full of microorganisms. Gram is that base, and so I'll move my decimal 3 places to get to milligram, and so this becomes 150 milligrams. Now I have a true proportion. The labels match, and so I can do the math. So the first thing that I do is multiply on this diagonal, so 150 times 20, and that gives me an answer of 3,000. Multiply on the other diagonal, so x times 500 gives me an answer of 500x. Then I divide both sides by 500. 500s cancel, so I get x is equal to, I do this math, and I get 6. My label is milliliters.